Okay, here is the video for the Algebra 1 with Lab review for your quiz tomorrow on percents and exponentials. Number 1 says Danielle wants to buy a new pair of Uggs. The price is normally $180, but Danielle has a 20% off coupon that will work next week. The tax rate is 8%. How much will Danielle save if she waits until next week? So her coupon is only valid for next week. So what I would like to do is kind of split this up and say, okay, we have what she would pay this week. And then we're going to have work for next week. So this week, she has to pay the $180 plus her tax. So now we have to figure out what the tax would be. So if we use our we have to get how much the tax is going to be, and the tax is a percent. So we can use our percent formula to figure this out. So remember, our percent formula is, say, is over of equals percent over 100, or part over whole equals percent over 100. So let's see. We have the part is the tax. So I'm going to write x over the whole is 180 equals my percent, which is 8 over 100. And cross multiply. 100 times x is 100x equals 180 times 8. Let me get rid of that, sorry. 180 times 8 is 1440. Whoops, that's not going to work. Hold on one second. So that's 1440. And if we divide it by 100, that would equal $14.40. So this week, we would have to pay the $180 plus the $14.40 in tax, which would give us $194.40. Now next week, if I wait, I have a 20% off coupon. So I want to figure out what 20% of 180 is. So I'm going to call that y over my whole price, 180, equals 20 over 100 this time, because we're working with next week's data, or coupon of 20%. And that's what we're doing right here. So if we cross multiply again, we would end up with, 100y equals 3,600. And dividing by 100, y is 36. But this is a discount. So my original Uggs were 180 minus 36 is 144. But this is the price without tax. I need to pay the tax on this. So now we have to go back and do the tax. The tax rate was, as we said, it was still 8%. But now it's 8% on $144. So I still go, I'll call it T for tax. The T over 180 is equal to 8, sorry, not 180. That's wrong. 144 equals 8 over 100. So if I cross multiply, I get 100t equals 144 times 8. Whoops, times 8. We get 1152. And divide by 100. And that t is 11.52. That's my tax. So to get the total price, I want to do 144 plus 11.52, which comes out to 155.52. That's how much Danielle would pay if she waits till next week. The question asked, how much will she save? So originally, if she doesn't wait, she pays $194.40. If she does wait, she pays $155.52. So we would want to subtract these to figure out how much she will actually save if she waits until next week. So we'll do that. It's going to be 194.40 minus 155.52, which equals $38.88. So she will save that amount of money. So the final answer is $38.88 saved. So I would want to wait. That's a lot of money. All right, number two. Number two says at the end of week one, a stock had increased in value from $2 a share to $3 a share. And A says find the percent of increase at the end of the week to the nearest tenth of a percent. Percent of increase. It's the percent. You're trying to figure out the percent of the increase itself. So if I go from $2 a share to $3 a share, we've increased by $1. So when I do my percent, I want to find the percent. So I'm going to do something equals my percent, which is X over 100. My increase is what goes on the top. The increase is the 1. Now, the denominator is going to be the original. So I want the percent of where it came from. That's what percent of increase means. So I'm going to put in the denominator a 2. So 1 was how much it went up by. It used to be 2 equals X over 100. Cross multiplying, I would get 2X equals 100 and divide by 2, and X is 50. Okay, and we don't even need to round that to the nearest tenth of a percent. Part B says at the end of week 2, the same stock had decreased in value from $3 to $2. So now it went down 1. It says, is the percent of decrease at the end of week 2 the same as the percent of increase at the end of week 1? Justify your answer. We're going to set up a similar thing. My percent is what I'm looking for. So I want to call that Y over 100 equals the change. I went down 1. It says, okay, so back to, oh, sorry, I had to pause the video. Someone had interrupted me. So we went down $1, but now we were coming from not 2, but 3, because it's the change over the original. So I have 1 over 3 equals Y over 100. So if we cross multiply here, we get 3Y equals 100. Divide by 3. And Y is 30. If we do this division, it's 33.3 with a bar over it percent. Okay? So is the percent of decrease at the same is the percent of decrease at the end of week 2 the same as the percent of increase at week 1? The percentages are not the same. Because the percent decrease is lower. It's lower in amount than the percent increase. And there we are. All right, number 3 says to graph the equation y equals 3 to the x on the interval -1 to 3. So this is basically a calculator question. So on the calculator, let me walk you through this. Sorry, I just wanted to clear everything out in there. You have your blank calculator, and you press y equals, and you go 3 caret x. And there it is. And now we want to get a table of values. So I press second graph. And we want our table to go from, if you take a look, this says x. If we read this this way, x is less than or equal to 3. And if we read this backwards, it says x is greater than or equal to -1. So I want to write my table from -1 to 3. So here's my table. Okay, starting at -1 and going up to 3. So you would want to copy this table down. I'm just going to drag it. But you would want to copy this table down from just -1 to 3. So I don't even care about the 4 and the 5. I just care about the table from -1 to 3. So don't even worry about those. Those aren't even there. Let me just do something real quick here. So this is the table I'd want to copy down, and now I want to do the best I can to plot the points. I'm going to plot the bigger points first. So I'll plot 0, 1, which is right here. 1, 3, which is right here. 2, 9, which is right here. And 3, 27, which is all the way up there. And we didn't plot -1 yet. -1 is 0.33333, which is actually 1/3, but it's very tiny, close to the x-axis. Now since they gave us this interval, we just want to connect the points with a nice smooth curve, but don't put arrows at the end. Okay. Then it says, will the graph ever touch the x-axis? The answer is no. Okay. The values, if you think about what's happening in the table, every time I go up through the table, what am I doing? I'm multiplying by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So if we go backwards, we would be dividing by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 0.33333. So the values are always positive numbers. They're never going to be ever level out, because if I divide by 3, I'm always going to have something there. So an easy way to write the answer is no, the values of y are always positive. And never 0. So the graph will not intersect the x-axis. And that's plenty. All right, number 4. Michelle invests $1,000 in the bank in 2012 at an interest rate of 3.5%. How much will Michelle have in the account in the year 2040? And this is, we're going to use our formula. Okay, our a times b to the x formula. And we don't even really need to even plug in. Most of you know what to do here. I have my value that I'm putting in, which is 1,000. That's my a. Times 1 point, or 1 plus, this percent, but I have to write it as a decimal. So I have 3.5%. I have to move the decimal place over twice, which gives us 0.035, or just take 3.5 and divide by 100, either way. So I have 1.035, and interest rates are given per year. I have to figure how many years have gone by. So if I started at 2012 and I want to go to 2040, 2040 minus 2012 is 28. And if I type this into the calculator, we'll get the answer. So I'm going to put in 1,000 times 1.035 to the 28th power. Okay, didn't expect that. Sorry about that. We're back here though, and we get this from our calculator. Now, if we're dealing with money, we would run around this to the nearest cent. So this, and I'll tell you what to round to in the quiz tomorrow. So this is $2,620.17. So if you think about it, this is over 28 years. We started with $1,000. Now we're up to about $2,600. Not that much money, because it's been in there for 28 years. All right, one more question. In 2014, Steve buys a new car for $22,000. The car depreciates, and they tell you that means loses value. This is important. It's losing value at a rate of 15% a year. How much will the car be worth in 2024? So again, we're going to use the same formula because it's a percent and we're going over many years. So we're starting off with $22,000. But now, instead of 1 plus the rate, because we're losing value, we have to do 1 minus 15% as a decimal, in which I move the decimal place over twice, I get 0.15. That goes right here. And now x is the time. So how much time has gone by? Well, I went from 2014 to 2024. That's, if you subtract them, that's going to give you 10 years. Okay? And we could type this directly into our calculator as is. So we have 22,000 parentheses 1 minus 0.15 raised to the 10th power. And calculator had a little bit of trouble. Let's see if I can get it up and running. Sorry about that. And we get this from the calculator. So now I want to round this. Again, it's money, so I want to round it to the nearest, I would say round to the nearest cent. The car will be worth $4,331.24. So think about that. Steve bought the car for $22,000, and 10 years from now, it's only worth, say, $4,300. That's what happens to your car over time. It loses value, and that's about appropriate. A little personal story. I had a 10-year-old car that got into an accident, and the insurance company gave me $4,600. So that's a reasonable estimate. And that car new that I had probably would have been around $22,000.